Progress.
After we get to and talk about your background, maybe this will be a good first topic of conversation.
Yeah,
It looks
I've been
like
in
we are
jail.
showing live.
I love the ad there. We're going to talk about John's time in prison.
I mean, so it was funny, John. So I was reading that, and Beth, my wife, looked at it, and she's like, "Oh, I don't know if you should put it like that." And I'm like, Beth, I have heard John introduce himself to like 4 different groups of people. This is exactly how he introduces himself. I started my time in prison.
I've been in and out of jail for 10 years. Yeah,
Exactly.
yeah. That's how I opened all my professor meetings with students, freshmen, brand new kids scared out of school.
I started my time in prison. Boom. I've
been in and out of jail for 10 years.
Maybe you're doing them a favor by scaring them out of school. No, just joking. We are a very positive schooling group here in manufacturing, on the manufacturing hub. We have a lot of people who have talked about a lot of continued education. Perfect. So I am showing that we are live. Here we go. So I'm showing we're live, and we got some people coming in. Hey, Frank, how's it going? But before we jump into the normal community comments, if you guys are watching on LinkedIn, LinkedIn recently did some changes. And so now they're kind of pushing everything into an event that is also, that is all kind of rolled into one. It looks different on my side, but if you guys, Frank, anyone else who's watching, if you guys wouldn't mind letting me know, I'd be interested to know what it looks like on your side, if it looks the same or if it looks different. This is a new thing that they've done. I finally think that I have figured out what LinkedIn is going to change on me this week, and then they throw something brand new in there. Beyond this, John, this is one of my favorite points of the community comments. I get to embarrass Vlad. So you may have seen that Vlad has a YouTube channel called Solus PLC. We are currently streaming onto it. So hey, everyone on Solus PLC. They have like 24,000 subscribers at this point, and the only thing that this show is missing is there are many things the show is missing, but the number one thing that this show is missing is a silver play button up and above Vlad's shoulder. So we are on the hunt for 100,000 YouTube subscribers. So if you guys are watching, please give Vlad please go ahead and give Vlad a subscribe and a like on this video while you're at it. He has recently been putting out a bunch of very interesting Siemens content that correlates with Preston Hadley's Change the Life giveaway. You guys may or may not remember Preston from a couple of our earlier episodes. Preston, once a quarter, goes through the process and gets some sponsors. This time it's Siemens, and he goes and gives away some like really awesome hardware. So this time it's a Siemens S7 1500. It's an S210 servo kit and TIA Portal V16. And the goal is to introduce people into Siemens TIA Portal and motion control. So he's at about 600 or 700 entries now. It ends, I think the drawing is the 1st. So the drawing is tomorrow, or the drawing is Friday. So if you guys are still interested and are watching this live, you guys should absolutely go ahead and check that out. The one caveat that I like to say is his goal is to help bring less experienced people in entry stage. If you're interested in automation, if you're like Vlad, who has the most impressive wall behind him, or like John, who has a slightly less impressive wall behind him, it's not necessarily for you. It's hopefully for people who can't necessarily afford the hardware themselves, to kind of give them a chance and an opportunity to learn a little bit about this.
Dave, do you have a link for the giveaway to post in the chat?
I do have a link, so I'm gonna drop this in. I'm gonna drop this in the LinkedIn, and so this is everything from Preston and everything that is going on with the Change Your Life giveaway. So you guys can check that out, and Vlad will go ahead and push that out to the other areas. Very interesting. We were having a conversation, and you guys stick tuned to our Raspberry Pi's industrial grade as we get into this. John has a bunch of very interesting background. And I know, Frank, I'm going to call you out because I see you in the chat, that we were having a very interesting conversation on this yesterday, like 45 minutes after we got off the call with John, or a couple of days ago after we got off the call with John. So I think that will be very, very good for everyone. Beyond that, we want to make sure to thank Copia Automation, who is sponsoring the DevOps and industrial automation theme. We'll talk a little bit more about them later, but I will go ahead and drop in the chat below. They're offering a free trial for anyone who wants to take a look at their modern version control. They're offering a free trial for that. And that's about all I have. Vlad, do you have any other comments before we roll into it?
I do not, Dave. Let's get us started.
Awesome. Everyone, welcome to Manufacturing Hub with me, Dave, and this guy down here, Vlad. We are very happy to welcome John Pillar on episode 31 to the show. Again, we're talking about DevOps and industrial automation. And without further ado, welcome to the show, John.
Thank you, sir. Thank you very much.
So as we were talking about, as everyone was coming in, you have a very interesting background. Do you want to tell everyone what you spent the first 10 or so years of your career working on?
Sure. So after graduation, after college graduation, I intended on being a electrical contractor. I figured I was going to do power and electrical contracting. That was kind of the family background. That was where we were at. I started at down in Houston, Texas, as 8th largest electrical contractor in the nation. I was the right under chief estimator, and it was going to be the Aaron Parrott for that group. Things happened. Texas wasn't for me. I moved back home to Indiana, and so I reached into my my controls training a little bit from college. We had a little bit of controls in my degree at Purdue, and using my building construction background, I started with a company called integrator.com out of just north of Indianapolis, Noblesville. It's now called Stanley Security Solutions, but we built jails, and jails are just machines that hold people. So as you like to say, I was in and out of jail for 10 years or so in some form or another. I got to go home every night. That was the cool. Well, I actually stayed over a few times because work, but yeah, I could have left if I wanted to. And the other little piece is that red wire to yellow wire unlocks door, but you got to get to that wire. So there is a color code.
Interesting. You heard it here, folks. Red wire to yellow wire. The difficult part is getting to the wires.
There you go.
I would imagine that's very difficult to get to them, John.
Yeah, generally speaking, if you're one of the customers, you're on the wrong side of that door.
Yeah,
and it's 3/8 inch of plate steel. So
I'd be curious to know. I guess so. Control systems in jail, is it primarily to hold like cells closed, or is there a lot more to it than that? Right? Because there's a lot of probably, I don't know, time-based openings. There's a lot of like controls that you can also watch, like certain cameras, screens, like what have you. There's also, it's not just opening and closing a door. Obviously, there's like feedback. Probably there's sensors and whatnot, right?
Sure. So the first answer is it's not process control. It is just digital on-off stuff. But the main controls are doors, intercoms, cameras, that kind of a system. So any facility had that. And I was actually talking with one of the guys that are on my team now about process control lines that we're doing today, and kind of coming back to the jail. When I do machine learning and when I do the stuff that I do today, we'll get to eventually when we start talking here. The fact of the matter is the machine was already working before I got there, and I'm adding capacity and automation and skill to it, right? I'm making it a little bit better, a little bit easier for the operator. Same deal happens with the jail, right? There's still mechanical doors. There's still giant brass keys, and the brass keys that you see on the movies, and you're like, there's no way that's what that is. It is absolutely a brass key that's about that long, about that thick, with a really weird cut to unlock these things. There's only 3 types of doors, 2 types of swing doors, and it's the way the mechanism and camming works on them, and then a slider door. Um, and then as far as feedback goes, you could have single indication doors, dual indication doors. So you had what we call door position switch, doors in the frame. And then you had lock status switch that said that the bolt is actually, it's bolted locked. So, or you could have those series together as a single input back. You could have those as two inputs back. You could have just door indication. You didn't normally just have lock indication, right? But along that way, and then we had icons that showed exactly that. We had a door icon that would show open. It would show closed in red if the door was in the frame but not locked, and closed in gray when the door was locked, right?
Mm-hmm.
So, and I got to preface all this. This was going on. We were doing Wonderware in touch screens. We built our own homebrewed SQL server. And I say we, I mean, the team that we were at. We had data management, logging of all activity, passwords, prox cards, and all of that was managed by who could unlock door what, all across the board. So we had a full, if you will, homebrewed MES that we were doing along the way. It was just in the jail, right?
What was the control system of choice? Is it like a specialty system designed for jails, or was it like Rockwell, Siemens?
I started with PLC 5s and Slick IO, and then we upgraded to Logic's platform, and we used a hell of a lot of DeviceNet and remote IO pieces. So I had that's what it was, all across the board, and it was it was an industrial solution to that condition. Yeah.
Yeah, it's interesting. You don't always realize, some of these, I would say, like real world applications that are not industrial in nature use the same components, right? Like we
Absolutely.
talked with Dave. I think we had a couple of guests talk about roller coasters and just rides in general, and that's all. It's all on industrial controls. But it's interesting to know that jails, I guess, as well leverage the same systems.
Yep, and you go. I mean, I had the largest system I had was in Northern Illinois, in Rockford, Illinois, Winnebago County. It had day rooms A through H with mezzanine, so 2 floors, A through H, and we had over 40 PCs that were touch points. So, and it was all direct connect in. So they had the PCs were in day rooms, and I built that whole network, had that whole thing set up, and you have fallback plans, right? So in their case, on the 3rd floor, it fell back to 3rd floor control. And when 3rd floor control shut down, it fell back to central control. But central control can unlock everything. And central control number 1 could unlock everything. And central control 2, 3, and 4 always fell back to central control 1. And we had that whole setup. I mean, it was quite massive. As I look back at it, I was thinking, we're just building jails. Let's move on. But it was a really cool. We were doing crazy stuff before we were supposed to be doing that kind of crazy stuff, right? I mean, we set up Telnet, so you had to have all those screens on all 40 of those machines, and we ended up setting up Telnet, and we built what we called the Commander Whisper, our touchscreen gateways or Dells at the time, where we called them commanders, and we called it the Commander Whisperer, and we would use one place where we changed the whole in-touch everything, all the screens. That was master control, central control, and at the end of the night when we were done testing, or actually at the end of the night, we were done testing, because you have to test it when people aren't there. We would then run the Commander Whisperer, and it opened up Telnet and rebooted every machine, as it ran. And we loaded all the software, went on to the next one, because it took 3 hours to move that across all 40 of those machines across the board. And you didn't want to do that, so we automated it.
Was there a governing body that kind of told you how things need to be done, or was it all like built in house and you had to figure out, like, I guess, like some of the things that you mentioned is redundancies, right? And so it must have been like some kind of a requirement either by the customer or a body that tells you that it is what's needed.
It's a building, so the architect.
Okay.
It was construction site, right? We laugh. I was in and out of jail, right? But most of the time it was a construction site. There, we had to do service, and so then there were customers that served when they were, when the machine building was live. But generally speaking, we were building a new building, and it was an architect. So there was an architect spec. And that's why my electrical contracting background was useful, because you have to, I mean, it was building a building, and it was a contractor in building a building. I had to go to the Friday morning meetings in the trailer and sit there and listen to the drywallers yell at the landscapers, yell at the painters, yell at the electricians, all that process that goes on in building a building. And then along with it, put automation and controls there.
And so what have you been doing since you got out of jail?
Since I got out of jail? Yeah. So after that, as you probably can guess, nobody puts jails where you really want to go. So I was traveling, but we didn't go cool places. So my wife and I wanted to, we got married, we wanted to settle down. So we moved back home to Northern Indiana. So I'm basically in South Bend. I'm a suburb of that, but I started doing just electrical controls for a while in this space. Started up my own consulting for a little bit. Worked for a company that was a startup, and I didn't really pay attention to how cool it was that I was working for a startup at this point. I don't know if I mentioned this to you, Dave, but it was called MNet, and now it's called, I can't even pronounce it. It starts with an X. They got bought, so it was a good thing Luis got bought out. But MNet was a startup, came out of Notre Dame, that put intelligence into sewer systems. And so I was working with them on putting flow measuring devices. They weren't controlling, but they were measuring and mapping the flow of the sewer system. And South Bend sewer system has over 170 points of measure, which makes it the smartest sewer system in the nation. So I was helping them do that, starting up my own consulting, and then professor of mine, Professor Mike Jacob. So some people may know him at Purdue, gave me a call and gave me an offer I couldn't refuse. He said, give me your resume and I'll hire you as a prof. So in 2011, I started teaching as the controls and power guy. My entire master's group all retired that year. And so I replaced 3 individuals for controls and power. Wow. In the professor realm there in West Lafayette.
Wait, did you move back to your university? Was okay, so
yeah, okay. So I moved, and wife and son, brand new son and house, were still up here in Northern Indiana, and I spent a year in West Lafayette teaching, starting up, learning how to be a professor. And there are extensions all over South Bend, or all over the state, called the statewide location, that the Purdue Polytechnic College of Technology at Purdue has. It's one of the extensions of being a state university. And somebody retired in South Bend. So I said, why don't you move me up there and get somebody hired into West Lafayette? There's that, Notre Dame up there in South Bend. So it's kind of easier for Purdue to recruit for West Lafayette position. And I already had a house and a baby and a wife. So in 2012, I started my position in South Bend, professor from West Lafayette, existing in South Bend. So kind of an ambassador. And at that point, it was me and 2 other electrical professors, a mechanical professor, and a IT industrial technology professor. And we had 4-year degrees that we were teaching. So at that point, I signed up for, I have 35 differently named courses by the time I retired that I had taught, or retired, moved on to the next spot. So yeah,
I taught
not everything.
One concurrent time, right? Like
what? No, but 35 different named courses. So I taught everything from, here's your freshman 101 class, here's your Ohm's Law class, to senior design stuff and process control and PLCs and all of that, and then across the board and I actually brought manufacturing engineering technology as a degree up here to South Bend. So and my title, so this is important too, kind of to my story. I was not a research professor. I was a clinical professor. Mm-hmm. So what that means in academic aspects is that I didn't have to go get grants. I didn't have to go do research. My job as a clinical was to bring industry into the lab, bring industry into the lecture room, and have real hands-on knowledge of what's going on. It's kind of equivalent to the clinical doctors that are teaching you in the teaching ER space, right? What are we doing today? I don't know. What gunshot wound comes in today? That's what we're going to learn on. So that's what I was doing. So to that end, I continued with my consulting group. I was blessed in the fact that South Bend only taught from Monday to Thursday. So I had Fridays open to go ahead and do some of my own work. In that way, I was also, on the clock because I was, a full-time professor, but I also used some time with what was called manufacturing MEP. So what is that called?
Manufacturing Extension.
Thank you, Dave. Yeah, we've talked about this.
Yes.
So Purdue has the MEP, the Manufacturing Extension Program, and I used them. I did consulting through them as a professor for Purdue, and I also did teaching. So I would teach in the PLC 101. I basically took my PLC class and turned it into a 5-day course, and I taught all across the state for that. So
sorry, what's the MEP program? What is that?
So the MEP program is in the States. There is a university in most states, usually a state-run university. So Purdue is ours, that runs the agriculture and manufacturing extensions. So everyone recognizes in the United States, we all recognize what the 4-H fair. It's run by the ag program of a university that's there in the state. Okay, and every county in Indiana has an ag extension. So if I have a weird plant or some kind, I could call somebody and pay somebody to come out, or I can call up the ag extension and they have an agricultural expert that can say, yeah, that's not poisonous, you're okay. Or, oh, we've got bees. Okay, they send bees to, someone to come get them and get them out of there rather than an exterminator to kill them off, right? So, and then it's also the place where the farmers send their soil samples, and all this work is done that way through the state. On that other side of the house, there's the manufacturing extension program, where we bring knowledge and research and potential to the state through the university from professors. And this all came down from, I think Abraham Lincoln actually signed the document for that, because they wanted to bring university knowledge from the East Coast out to, the great barren west of Indiana, Ohio, Illinois, kind of stuff, so that we could advance that way. So that's what that is.
And so after academia, you decided to move on after all those courses taught. Why? I guess it seems really interesting, right? Because you're passing down knowledge to many individuals that I'm sure you're still connected with.
So the teaching is what I am born to do. Absolutely. Frankly, though, academia has some politics that got really old, and I got tired of fighting them. I had an offer I basically couldn't refuse that came through my consulting gig, to go work with a startup out of New York called Liveline Technologies. And they had a field deployment team, and I was going to be their senior engineer on the field deployment team. And basically they needed an old guy like me that knew how analog signals work to get it into the data stream so that they can do their data presentations and ML and all these other IoT type things. So I was working on that process. So that was 2019. I did that. And kind of to lay out where my burn in the Raspberry Pi world, they had a great deal of fleet of not directly Raspberry Pis, but more industrial Raspberry Pis. They were part of their data collection system, because that was an easy to use, and I'm going to use the term senior project solution to go out there and start doing proof of concept. That's where I come down on saying it's not the ideal solution to move on to the next step. It's good for proof of concept. It's good to allow you to build and show fast and quick and do iterations and all the beautiful things that I love about startup. But as you move forward and you need something that lives, 20, 30 years, right? And I just talked to a guy that had a machine at Rivian that was 23 years old, and it had a PLC that I had never even heard the freaking name from. And the thing is moving and working and doing its job, right? I'm going to challenge that appeals. A Raspberry Pi isn't going to do that. It's not designed to be that way. It's not intended for that. It's intended for quick, fast lab setups. So we had that process, and we moved on from that. And from moving on from that position, we kind of ended the field deployment team. So I had an option. I could have stayed. I decided not to. I decided to just go back to contracting and just machine builds and whatnot back here at home. And so in March of 2020, when the world started shutting down, I quit my job and moved to a different job. So, and I did that for a while. But I tried to actually help a gentleman who was an electrician move his service department type contractor into a machine builder. And he decided after a year he didn't want to do that anymore. There was enough money in 3 guys in a truck that he didn't want to have to go down and do the real engineering work. He's probably got a different plan on that, but that's the way it kind of worked in my mind. So we moved on from that place, and I started hunting and finding my team that I'm going to do the next magic with. And that's kind of where I'm at now. I'm with a company called Liveline, which is a subsidiary of Cooper Standard, and we're part of the R&D team for that process, and we're adding ML to our lines. It's a lot like what I kind of did at Odin, except it's data collection, and I'm working in pulling in all the data there at Cooper Standard, and we've got a great deal of sites all over the globe that I'm going to get this system put in on. So it's really cool.
You want to give us
in a nutshell now?
Go ahead, Dave.
I was going to say, I would love to talk more about the ML that you guys are doing currently, John. But before that, we've got people in the chat that want to hear this conversation of our Raspberry Pis industrial grade, right? Should we use boards? Should we use, all-in-one controllers? I think you kind of laid out your thoughts. I think Vlad might have some different thoughts. Vlad, you kind of want to share? For anyone watching, you can see 5 of Vlad's, I think, Raspberry Pis in a 3D printed holder on a DIN rail. So I feel like Vlad has a slightly different opinion. Vlad, would you kind of like to share your thoughts on what you've been doing or looking at doing with Raspberry Pis?
Well, I think me and John, to some extent, agree that they're excellent for prototyping. I would still be cautious of putting them in an industrial setting. That being said, I still think that they're very cost-effective compared to other solutions. And I think when implemented properly, again, because you can very easily create like dual redundancy or triple redundancy using the Linux platform, you can very easily swap them out if they were to fail. But obviously, as experience shows, in very hot environments, very humid environments, they are going to fail rather quickly unless you invest in a ruggedized Raspberry Pi solutions, of which there's multiple on the market. But yeah, I mean, I think ultimately what the industry is looking for is rugged Linux computers, and usually the price point for them is not that low as compared to the Raspberry Pi, and that's why everybody seems to gravitate towards them. But obviously, I guess the lower price point has a trade-off. So, John, what are your thoughts on that?
So first of all, and when we first met, Vlad, I told you I am often the old man screaming at a cloud, and I get that, and I hate that I'm that guy, right? But as and I've been through a lot. I've been through the PLC 5s and all the way up, right, and back and forth. So I've been through the growth of I have nothing but serial communications all the way to Ethernet and all this, like a lot of people do and have been. But so I'm cautious on a lot of pieces. I got burned pretty hard on the Pis. While you're correct in that you need to keep it cool and all these other good things in an air conditioned space and in a very hot space, my Pis were all cooking at the same temperature. And so it wasn't about the space, it was about the nature of the Pi itself. And as I understand now, the USB 3 has a separated UART, but part of the biggest problem we were running into is that the UART was serving both Ethernet and serial comms. And so we were pegging the serial at envelope's edge and we were pegging the Ethernet at envelope's edge, and it was just baking the board. That's basic board level electrical. So if I take off my electrician hat, and my 3-phase and controls guy hat, and I put on my Ohm's law and resistor and down to my microprocessing hat, I go, what kind of a jack of all trades went and designed the board that way? And it's somebody who doesn't understand, or somebody who uses a board and designs a board for in-lab use, not for production use. It wasn't designed for that. It's open source enough, so if you want to use it for production, go make a production board for that, right? That's what that's for. And so, I put on my embedded processor guy hat and I go, this isn't what we're designed this for. This was designed for prototyping and moving on. It's not like you're going to go out there and take NI DAC systems and MATLAB and say, here, that's good enough. No, I can make my algorithms and use all that and do this process through that lab data stuff, and then take that and go build the product. That's the process. And that's my old man shaking the fist. We got to get out there, get it iterated, get it fast, show it works, get the money, get the funding, make the product, sell it.
Well, let me ask you this. Was temperature the major limiting factor? Because you could have also, and I guess this is more of a question, could you have stuck a big enough heat sink to dissipate the heat, right? Because you could calculate how much heat is being dissipated by the processor. And
it was the temp on the chip. So it
Right.
wasn't like I was measuring. It was the reported temp coming from the chip. And the reported temp coming from the chip was 20 degrees C above above rated temp.
And so even with a proper heatsink, there was nothing that you could do.
Even with it open in an air-conditioned room and all that fun stuff, fan blowing on it, it was still cooking at 85.
Mm.
So, it was just the nature of the beast. These things were eventually going to start dropping off. And this is the other piece that I've been talking, the data in the cloud and everything that we do there is awesome, but it's only as good as what I can grab from the machine and hand to you. And if my pipeline going up that way fails, everything else sucks. Nothing else matters. That's the beauty of IoT, and that's the problem of IoT. The weakest link is this old RS-485 stuff, and that's where it is. So that's when, before we cut into the talk here, that's kind of where I was going with you and saying the first question is, what do I already have? What data do I already have? And I have it on the PLC. It's there on the PLC. The PLC is using the logic for it, but I have sensors on there. So why do I need to add why do I have to add other sensor points when I already have sensor points giving me the information I need? So you have to harvest it off what's already existing there. And that's hard. And, I think you were going down that route saying Rockwell isn't open. It's not Linux. It doesn't MQTT. There's a lot of all this going on there. You're right. So then my answer is, what your job is to go and harvest that data. What I look at it is I have to harvest the data. I have to see what's first there, harvest the data, get it into a central database. Once it's in the central database, once it's Ethernet based, right, on the floor, then I share it up. So right. The other problem with the MQTT, this distributed Raspberry Pis across the board, is each of them are separate pipes going up, and depending upon Wi-Fi and all this other, I currently have microwaves that are vulcanizing equipment or vulcanizing the product that's going through. These are going at, you can't Wi-Fi in that space. You can't Wi-Fi in that building because I've got a microwave that stretches 300 yards. Mm-hmm. That it just Wi-Fi don't work, man. So Raspberry Piing the snot out of that is no good. My cell phone doesn't even work in that space. So these are just the facts of the matter. You have to smell it and taste it and know what you already have and then dump it up. And so to me, it's about making sure that we understand that the machine that's there is already doing its job. It's already working. It's already making product, and it's paying its bills. Anything that we do in IoT is making it pay better. And first of all, pay for the product that I'm putting on there. And second of all, pay for my salary. And then after that, it's gravy, right? So those are, we're eking out pennies because they've already squeezed all the dollars out of it at this point. So that's the first thing that data scientists and the people in the cloud that are doing stuff need to understand. They're not coming in and solving my problem. I didn't have a problem, right? I just need to be better. Two, there's already data there. Let's mine it. Let's use it. Let's gather it, get it in the way, and get it to a central spot. Because if I can think of it that way, I can get you more data, right? If I can think about it on this line, if I have this line, what do I have to do to get data from that little analog controller that I can go get an RS-485 card for? And maybe that's an appropriate use for a Raspberry Pi. I don't think so. I think it would be better to go get a Wago or go get something small, cheap, little, even that stinking click that's on the back of my wall, right? Get that's designed for industrial space, get it gathered, and then get it passed up to something that's an IPC at this point, right? So now you're in the Beckoffs, the B&Rs, and those other locations. Or just go ahead and have the remote IO that's up and down your line that's doing all this. Once you're in that spot, once you're in that place, when you start thinking of it in that manner and using the tools that we already have on our shelf, right? And getting it to the point where now it's data collected. Now I'm doing all of that in level 3 and below. I'm still on my side of the firewall. I haven't even passed it through. I don't have all these little pipes going up and up and up and up and up. I'm making the local IT guy happier. I didn't make him dress out Wi-Fi all over the place. There's all these other pieces to that pattern that when you say, let's just throw Raspberry Pis out there, and I know that's not what you're saying, but when you throw the Raspberry Pis out there and you do that, there's all these other cascading problems that are caused just because it was a quick, simple lab level, POC level solution. We have to put a product out there.
Sure, yeah, I guess like my idea of that infrastructure would have been like multiple Pis going into like an IPC, right? That would sit also on the OT side, and then that would funnel your data into like the IT, whatever database.
So use the remote Ethernet based IO that goes to the IPC, because that's why it was created for, right?
Yeah. I mean, there's multiple ways. I mean, like, so what I've seen as a critical component for getting data, I guess, from the plant floor, it's reliability, right? So your assets don't necessarily have the best of connections, and there's usually problems, I guess, getting from that like field device to your database, which either sits on-prem or sits on the cloud, right? So you want that edge node to not only be like a pipe, funnel, whatever you call it, you also want it to kind of buffer and maybe to some degree condition the data, right? Because again, you have to have your algorithms either you can write them on the PLCs, right? So if you have a PLC in your machine and you want to do, for example, on change data, so that's not native to, let's say, Allen Bradley, and you can write some fairly straightforward algorithms on the PLC, but a lot of times on the older PLCs, you don't have the capability. On the newer PLCs, you don't always have the space. And so you need some intermediary device that would do that for you, right? So it's not...
Absolutely. The PLC that's on the line is the one that's doing the job making the product. So Don't mess with it.
Exactly.
You can pull data from it and harvest data from it. I'm not saying add algorithms to it, right? Even if it is a Davis standard extruder, right? Mm-hmm. They don't want me to change. If I start changing IO and logic on their PLC, guess who owns that PLC now, right? I don't want to do that, but I can ask them, hey, can you give me read capabilities for this memory block and dump it over, allow me to pull it here through OPC, whatever, these capabilities, right?
Sounds like you don't want to come in at 3 a.m. That's what
right.
I'm hearing.
No, that's the other piece is I am not the manufacturing controls engineer. That's a farmer. I don't do farming. I build stuff. I come in, I let you have it. I show you how it works, and then you maintain it. I'm not a maintainer. I'm a builder, and I move on. I didn't stay at the jail. I didn't maintain the jail, right? I came in, you paid for an annual PM, and what I did is I walked around and showed you what you didn't take care of for that, entire year. Right. And so we took care of it for those 2 days, and you paid me dearly for it. And then I moved on to the next place. I have to bring a product to them to pull the data that then goes to the data cloud. Right. And you were absolutely true and correct in that if you have some now defined as mission critical, right? Because as soon as you add extra extra gravy to the line, it becomes mission critical, right? So now those are things that it has to just work. You have to have that local web server, that local algorithm, that local short-term storage pace, so that you get a week's worth of data. No, it doesn't hurt the process engineer. It doesn't hurt the manager of the building for him to call me up and say, dude, I lost the internet. What's going to happen? I go, you only get a week's worth, man. Go call Comcast and get it fixed. That ain't on me, right? So, and that's part of my contractor in my mind. I never want to leave someone hang, right? But I also want to make sure it ain't my fault. That's how you come in and become. I don't want to be a firefighter either. What I want to be is a hero and a solutions master, right? And Elisa and I kind of got into a conversation kind of on this a little bit. She asked a question on LinkedIn about how do you fuse your IO? My answer is, if you're fusing your IO, you did everything wrong, because you're using a fuse wrong. A fuse protects wires, not inputs. That's what it's designed. Let's open up the NFPA and find NFPA 70, the NEC, and find out what an overcurrent device is designed to do. What you're worried about is transient spikes that are coming back because something foobarred down line. Yes, it was the sacrificial lamb. Yes, it saved the day. No, the answer isn't to go grab another fuse, shove it in there, and walk away, because that's just the canary in the mine. The same answer is, hey, I got another bird, put it in here, take out the dead one, keep working, guys. It's methane. You got to solve the problem and not be the firefighter.
Hopefully, at least you put in the fuse of the same rating, right? Because we all know.
No, you got to go up, because the last one blew. You need a larger fuse so it doesn't
and that's
blow.
the problem with it, right? You just go up, because and then it gets down to I take a number 12 wire and I cut it and just shoved it in there, right? And so now it's 15 amps. It's all good. Or 30 amps.
The fuses keep blowing, John.
Yeah, that's the problem. No, that's not the problem. And I understand the mentality that gets us to that point, because again, that's the farmer, because he's got to keep the machine running. I get it. But it's about, now there's the teacher that kicks into me. Let's solve the problem, because you don't want to wake up at 3 a.m. We'll solve the problem. We'll spend some serious time finding the solution. And I understand, well, it costs me $1,000 an hour, or whatever the number is, the dollar amount per hour that the machine is down. Yeah, but let's take it down now in a controlled condition when you can deal with it, fix our problem. And you're going to probably, over time, because you're not going to have to keep replacing those fuses and having half starts, you're going to pay that money back. That's what Dave's, going to do the math for you and show you that the value is.
Absolutely. And so I love that, John. And I generally agree on the concept of run it all into a data collector IPC, so something along those lines. But I think that the big question becomes scalability, right? I think I think people look at the pie, because you can buy a $20 pie, and you don't necessarily think about all the other costs going in, but you can nearly infinitely scale a $20 pie and kind of throw it on the line and put some sensors on it and collect data and push that up so all of the data is standardized, versus having to go in and actually interface with the PLCs. And so we interface with the PLCs and we pull it into a data collector IPC, and then that gets pushed up, and there's a lot more work. And I am not going to disagree when we say that it's the right way to do the job, or theoretically the right way to do the job. But what would you say to the people who say, Raspberry Pis are so much cheaper, it's just easier to slap one of them or 50 or 500 of them in than it is to go through and try to scale across 50 different facilities?
Until you have 50 different clients that are dependent upon your entire fleet, and you're paying two guys 2 salaries of doing nothing but going to the fleet management and rebooting them to keep your data flowing because they're overheating. So when you start to compound that, if all you're doing, if we have got Dave, John, and Vlad manufacturing facility, heck yeah, let's go ahead and just use some pies, because you guys we're gonna keep it up and running, no problem. But now if you're going, it doesn't scale. That's the exact answer that I have to you. It doesn't scale. If you have to now be in charge of making sure that that data pipeway is the one thing, the weak link of everything in the cloud. Anything that you're doing machine learning, you're doing just OEE, you're doing just dashboarding. None of that is worth a damn once you lose one of those. You know, each one of them, you start losing them. And so do you want to have a fleet of trucks and dudes that are out there replacing them all over where they're at? Or do you want to spend the time to manage it and do it right on your downtimes? So you spend the time, you do it right, and you bring it on, you bring it on, you bring it on, you bring it on, and it's done, right? So, and then you have a facility and a thing that runs for 23 years, and you can sell to someone next. You know, those are the processes that I have the answer to that. It's not wrong when you do something really fast as a firefighter. Absolutely. You solved the problem and you moved on, but that's not the long-term solution. It's not scalable.
No, I appreciate that. Vlad, I know that we have to continue to move on, but do you have any last thoughts on this other than we probably need to have 6 more hours of manufacturing hub conversation on it?
I mean, I'd be curious to benchmark it myself, to be honest with you, with the temperature. I'm curious, and again, I'll do some research off camera if there have been solutions, because I would assume that it's the same problem that everyone's running into, right? It running over the temp that it's been specified to do. So I'm wondering if there has been a solution that has been developed for that specific purpose. But I mean, I agree, if that's the limiting factor and that's indeed the case of what happens, then obviously it doesn't make sense to have a fleet of people constantly servicing them and making sure that they're running. So I mean, I think you're obviously losing on the cost difference, right, that you're saving up front. So
it always costs more to do it right at the beginning.
Than it does to do it wrong 27 times before you decide we can't afford to do it wrong anymore.
And I'm going to say it's not wrong, right? I said it has its place. It has its tool, right? How many hammers do I have in my shop? I've got a claw hammer, ball peen hammer, rubber mallet, and an engineering hammer. And all of them can drive a nail, but some of them aren't designed for that, right? And only one of them can peen metal appropriately, right? It's got the process. Only one is going to pull a nail, right? It's got the right use, but they're all a hammer. So that's the real answer that I have to the case. And a smart professor once told me, or he was just a mentor, he wasn't a professor, but you know, there's the glass of water, it's half full, it's half empty. That's the normal population. The engineer says the vessel is twice the size of what it needs to be, right? It isn't, you got to have the right tool for the job that you're looking for. And you got to look at the constraints that you want. If the answer is this is a POC and I need to prove to the CEO, the COO that this is a good thing to do, yes, Vlad, go use Raspberry Pis because I can get that done really quickly on a Saturday. But if it's because I want something for long term, well, then I need to have worked in and baked into the description to the COO. I'm going to have to do this, and we're going to roll into an IPC, and we're going to go do this, and we're going to go down that entire route of the unified namespace and moving it into the cloud the right way and doing all these things. And the reason I do that, if I can pull it all into one spot in one place in my house, right, then I've got it all right there. Once it's all right there, if I decided I wanted to use Odin Technologies, I wanted to use Liveline, I wanted to use Site Machine, they all just go right here. And now you're interchangeable. If you go and you distribute all these Raspberry Pis, well, I've got an MQTT broker that's got to go to this, got to go to that. You know, you've got this other problem. So it's an interconnectivity piece, right? It's a future proofing and allowing you to be able to say, I got choices for data collection. I've got choices for ML along the way.
Well, I mean, like it's a multi-level stack, right? And your lower levels need to be right in order for the upper layers to make sense. And as you said, like the data is obviously going to be garbage if you're not piping it in correctly. But I mean, I think we're on the same page. I think maybe I just haven't experienced, you know, the same hardware failures on the Pi as you have. So I certainly, you know, cannot relate maybe to those challenges because I haven't seen it on a commercial scale where you had them distributed on multiple sites. So perhaps, you know, I would definitely be like 100% convinced that they're not ready for the industry if I was to go through that. But no, I agree with you that it definitely needs to be the right tool for the job. But I want to, John, I want to talk a little. Dave?
I absolutely want to talk about what John is doing now.
Yes.
But before that, I need you to give me that awkward laugh so we can tell everyone who this episode is sponsored by. Perfect. So everyone, this episode and the theme is sponsored by Copia Automation. They deliver modern developer tools for industrial automation. It's built for automation and controls engineers. Their flagship offering provides Git-based source control for PLC programming. It's currently native and fully functioning with Allen Bradley Rockwell, as well as Siemens and Codesys. Functionally, it includes version control, change visibility, and collaboration designed to streamline how industrial machines are commissioned and operated, resulting in faster delivery and maximized uptime. And John, I know that you have a little bit of experience with Adam and Matt, who are actually in the chat.
They're really cool, Adam. Hey, Matt.
Perfect. And so the first conversation I had with Adam and Matt was shortly. It included a conversation. It included the first conversation that you had with those guys. Do you want to? Do you kind of want to share how that conversation went and a little bit of maybe the research that you did, the conversations you had after that?
So yeah, so Adam and I had a shared contact, and so Adam needed somebody with industrial experience to kind of give a yay or a nay or a yes or kind of a thing with what he was doing.
Mm-hmm.
And he showed it to me, and I said, yeah, I know what Git is. Why would I have anything to do with that? There's no reason for that to exist. Why are you doing that, man? I appreciate it. You're off base. The OT folk don't do that. So, but along with that, he and I and Matt had conversations along the way and helped guide where they're at. And I think I hope I helped guide. I think I at least provided a little bit of insight on what goes inside my brain, and they did an awesome job. I am so proud. And I screwed up, Matt. I apologize. I didn't wear your t-shirt today. So
So with that, John, you kind of said, your first thought was absolutely not the old guys, and you don't really seem that old, John, but the old guys of industrial automation refuse to change, refuse to do anything new. I would take it that you have kind of softened on that stance.
Yeah. I mean, there's a lot to it. There needs to be source control. Absolutely. And the whole idea is, I mean, if I go back to thinking about where I was with the jails,
Mm-hmm.
It would been great to be able to just dump up and say, hey, I've got this commit done and this jail's good. And instead of having, here's St. Joe County, Indiana version 1, St. Joe County, Indiana version 1 dated today, St. Joe, and that's, I mean, that's what we did. Right. And we continued with that pattern and hoped that Rockwell back files were going to be good enough for us to remember where we were. So yeah, it's worthwhile. It is a good idea.
We have a question. I wanted to throw this in while we're not too far from that conversation. So Philip asks, are you aware of any smaller, more reliable solutions that are capable of popular protocols in order to send data to its respective destination other than purely the Raspberry Pi? And we had one answer from Benson. So he recommended the Rio from Opto22. But what are your thoughts, John, on that front? Or did the company find something to migrate to? Are they still on Raspberry Pis maybe? And what would be your thoughts?
No, they're not on Raspberry Pis. Hence the reason the forward deployment team does not exist.
Mm-hmm.
No, so the easiest, and I've seen the Optos and I haven't yet played with them. They're on my list, but it's a different world. I've moved on from that space, so now that would be in my free time, somewhere around the 45th or 6th hour of a day that I would be working on something like that.
So plenty of time.
Yeah, plenty of time. I run on a 36-hour day, generally speaking. So yeah, no, we didn't. What the answer is, as far as in the startup space, is you decide, are you going to be a hardware or be a software solution? And so that's kind of the mentality that I have going on right now. I know how to architect the solution, and so I'm going to be that architect, just like it was in the building of writing the spec of how it needs to be, and then I'll ask about two or three of the local talent in each of my spaces where I'm going to go, and and say, what are you going to do? Can you do this? And then help manage that for the client. The idea is the client does their job, they make their product, and they don't have time to manage all that. And so if I have a client that comes in and says, Pillar, I need your solution. I want your solution. I'm going to go sniff test them. First off, do you have an MES? If you have, what do you got already? What are you doing already? And I might be able to go ahead and hook to that and pull through and hand it off to the engineering team. But if I can't, then I have to say, well, we're gonna help manage and architect your solution. I might call up a Dave and say, hey, do you happen to be over in this side of the country and you got time to deal with these guys? That kind of a deal, and pass that off so that they can get themselves to be an IoT ready site. So being an IoT ready site is more important, I think, in the long run, in building the cables and the wires and the transmission lines to get us to the power plant of the cloud, than hurrying up and getting a bunch of individual little pieces. So maybe this is another answer, kind of an idea, analogy that I have in my head. I kind of feel like we're at that spot where, we got Edison solutions, we got Westinghouse solutions. I don't really know what we're going to buy, but I know we need to have wires, and I know we have to size them appropriately. I know I got to get some kind of outlets to these locations, and I got to get it all pulled to a power panel, right? And once I do that, that's kind of the part of this industry 4.0 that we're in. And this is when I say I'm the old guy, well, I'm the guy that's going to help build that transmission line, the distribution system, and not be dumb and not connect to the east and the west and just be Texas, right? We want to we want to make sure that we line it all up. All right. I don't know if it's AC or DC. I don't know if it's VHS or beta. I don't know any of that. But I do know that if I get it into a database that is a generally recognizable database solution, I'm going to leave the client with their best level future-proof solution along the way. And that really ultimately is what matters to me, is moving that next step forward, because that's what we got to do. And not to harp on it, Raspberry Pis don't fix that for me. They're just Edison coming in and saying, buy my power plant, buy my light, buy my stuff, let's move on. And I'm going to go kill Jumbo and show you that AC is deadly, so that's the process that I look at it. So I think the Opto is kind of cool. I think the Beckoffs have a good place in this space, the lower level Beckoffs that are just really cool little PCs. I think B&R might be good. I haven't played with those yet. The Wago in my back, I bought that Wago and I have yet to even power it up. So, I haven't even had a chance to play with that one yet. Maybe it'll be all right. I have a feeling that the Beckoffs and the Optos and the B&Rs are going to be better choices. That being said, I am freaked out like no tomorrow that an IPC is even talked about as being a controller for a machine, because I lived through the Rockwell soft PLC lifetime and the Windows blue screens of death that shut down jails. So I'm also been burned there, but I've coming to like it a little better as we go on.
I don't know if IPCs, I'm on the same page with you on that one. I don't know if IPCs are ready for controls per se. I'd be more of a proponent of using them for data collection, right? And more of a, pipeline for your data analytics. But yeah, I'm hearing about that too. And I think there's some gray areas that are starting to get maybe stepped over, but I haven't seen it maybe in an industrial environment yet where it's doing pure controls.
Yeah, I had a lot of conversation with a Beckoff salesman named John Tran, and he walked me through a lot of it. He listened to my problems, and the one benefit I have is there's a Windows version on there that's been locked. It will never accept updates, and really that's the problem, right? If it just randomly grabs an update and what does this do to my machine, that's a problem, right? You can't do that. And that's what was happening on our soft PLCs back in the day. That's what was going on there.
I've heard some similar opinions of that.
Yeah.
Go ahead.
No,
Dave.
I think all this is interesting. I appreciate Phil's question and Benson's comment. I would be interested. I've always kind of considered maybe the Groove as a good solution for something like this, but perhaps this warrants some additional testing. I don't know what the testing would necessarily look like, but I feel like that might be an interesting theme as we get further into the year, as to some testing to see if people would be interested in doing some comparisons, and maybe getting some experts on to figure out what the best actual solution looks like, or maybe what a series of solutions look like, and maybe we can answer the questions re IPC and control. I think everyone who does control with IPCs are going to be on one side. I think everyone who doesn't is going to be on the opposite side. But maybe it warrants some testing and some additional conversation.
I think that line is called the Rocky Mountains. Everybody on the West Coast is like, "Yay, IPCs!"
Yeah, I mean, yeah, most of the people that I know are in the Rocky Mountains, in fact, in and west. But I think that warrants some additional conversation, and maybe Vlad and I will have to have some conversation and reach out to some people to see if they would be interested in being part of some theoretical thing that we are apparently talking about live on the air at the moment for some reason. But so everyone's going to have to forgive us. Every time John and I get on, we just talk and talk and talk. And we have now hit nearly the hour mark, and I'm about to ask John the amazing things that he's doing. So everyone buckle up. We probably have 10 more minutes left. John, can you tell us about the awesome things that you're doing at Liveline? Because we would be remiss if we did not ask you this question.
Right. So we are in the process of doing the things that I didn't quite think were going to be likely possible, but in a very controlled way. We are to a point where we are taking over a line and putting it on auto control. So we have about 4 lines that are out there doing it, and it's really kind of cool. It's amazing. It has all the problems that Vlad was saying that we have to worry about. Where do you put the controller? Where does the control exist? What happens, and all the fallbacks that have to exist there. It's not a lot that I can really say about it down the round, but yeah, we're running a machine from the cloud with some machine learning. So it's really cool.
That's amazing. I would hope that we can continue to have some additional conversations as you guys get further into it, and maybe as you guys get a couple of case studies. You might be the list of people I know actually doing anything that even comes close to machine learning in actual production.
I was excited to be invited into the team. So yeah, this was great.
Absolutely. So I would say that we should absolutely keep in contact with you and what you and the team at Liveline are doing, and hope maybe before the end of the year, early next year, we can get back together and talk about what I hope would be a success story. Maybe you guys will have a case study that we can talk about. And I think that the point that you made earlier, John, was very good. That just only one good point, John. But no, I think the point of, by the time that we've gotten to like IoT, by the time we've gotten to machine learning or artificial intelligence, we've already saved the dollars, right? The folks like us have come in and we've built MES systems, and we should have hopefully saved the dollars, the big rolls of money. Hopefully that will be saved. And by the time we get to a machine learning or artificial intelligence solution, we're looking to kind of squeeze out the pennies, and best case scenario, the pennies are going to add up to significantly more than the cost of the many dollars that we've put in to get to that point.
Yeah, and that's absolutely the point of the whole process. First of all, resources are going down, right? Mm-hmm. So the input of cost is always going to go up on raw material, right? It's not going to come down. So you've already squeezed as much as you can out of that spot. So yeah, we got to get it in on the scrap. We got to get it in on the efficiency of the run. And if you're running at 97% efficient, 98% efficient is where we're aiming, for the next step. 97.5% more, efficiency is good. And you're talking about dollars per day, per line, per shift. Mm-hmm. Once you start going into that compounding, everyone knows that matters along the way. Yep. Electricity is more expensive. I got an entire class. I didn't even say, hey, I also teach classes in Germany while I'm doing all this on my fun stuff, and it's all focused on energy and energy use. Okay. All the costs aren't going to go down. We have to be conservative on the resources that we have available, and that's what Industry 4.0 is going to allow us to do.
Absolutely. Hopefully. I love that. I've got a couple of final questions. And first I'll ask Vlad if he's got a question, but Benson has come back with a comment saying that their customers are putting Rios where Raspberry Pis have failed, particularly if they need a few points of software configurable I/O. And there's also Node-RED and the need to secure devices on the network. So I think that is interesting. We had Benson on one of the earlier episodes. Benson, you'll have to forgive me. I don't remember what episode it was, but it was a great conversation about what they're doing in manufacturing. They're in California, John, so don't worry. They're absolutely west of the Rocky Mountains. But Vlad, before I kind of ask the rest of the wrap-up questions, do you have any other last questions for John?
No, I honestly really enjoy like where the conversation was going. I think it'd be, you know, like one idea that kind of sprouted in my head. It would be almost interesting to create some kind of a chart, you know, that you usually find in technical manuals. Like I know Rockwell has this, but they would say, if your solution requires this, like go with this platform. If you're looking for this, like go with this platform. So it'd almost be very interesting to see, because I think there's a different, you know, line of products, and even within the Opto 22 family, as we've mentioned a couple of times, those I think controllers would serve like slightly different applications. And so it'd be really cool to have a very large chart, I think, put by a third party that would say, you know, if you have like these requirements, like go this route. If you have like these requirements, go like slightly different route. Obviously it would require some kind of bench testing, and you'd probably have to power on that Wago. But I think like as a long-term project, it would be a really cool, like again, because I think like the industry will self-select, but I'm sure there's different ponds of people that are doing the same research and figuring out what makes sense for them. And so to aggregate all that research would be, I think, really interesting. But in any case, I don't have a question. I think we're over the time
Absolutely.
as is, but we can certainly continue this conversation later on.
Absolutely. Yeah. It feels like Vlad just committed, at least himself and maybe all of us, to a significant additional workload in all of John's free time. But John, speaking of your free time, you were a professor. You still teach classes. Do you have, I like to call this section our non-sponsored Audible segment, in which I ask you if you've got any book recommendations, preferably in English, not German, because I know Vlad speaks English and French. I don't know where German is on that list. But if you've got a couple of good book recommendations, Vlad's going to go purchase them, as well as I'm sure a few other of our listeners. What do you have for us?
Well, first of all, my German university classes are in English, so let's be clear there. I can order a beer and do some banking, but that's about it. So what I've always done, and I think you're kind of hinting at what we can look at for technology of today, you know, those kind of books that I would be pulling off the bookshelf now. What I've done with my students is force them back to thinking about the books that they should have read in high school and they didn't. So what I like to think on is, first of all, Frankenstein. I'm making my son read Frankenstein for fact, and actually understanding that Frankenstein's the doctor and not the monster, and the whole process of that. There's a lot going on with our technology that is an important story to read and understand. Lord of the Flies and Animal Farm and a little bit of Grapes of Wrath isn't too bad, because, and H.G. Wells' Time Machine, because I am a proud Morlock and a thought criminal, 1984, and a disciple of Tom Joad. So yeah, there it is. So
I love it. I love it. And a point for later discussion the next time John comes back is we're gonna talk about his love of Star Trek. And maybe how he and Adam, to go back to the first episode of this theme, probably bonded over their strange love of Star Trek. And
there was a solid bond there. Yes.
Okay. Now we understand how the industry goes around. No, I appreciate it, John. This has been great. One last question for you is who should reach out and connect with you? What do you want to help people with? What do you need help with?
I do need some teammates. So if what I've mentioned sounds a little interesting, I need some teammates at Liveline. I am also, like I said, I do energy and energy audits and that kind of stuff. That's kind of one of the free things I do on the side. So and anytime you want to cause any controversy about some new technology, I probably will mention something on LinkedIn and get yelled at somehow or blocked, or, you know, who knows. You know that, Dave. So
Yes.
I am a shaker and a mover, and I tick people off. So, and I
Okay.
don't mean to. I just tell my truths. So
He's just like that. No, that is amazing. I appreciate it, John. You and I apparently need to have a conversation about energy audits, as that has come up in non-manufacturing hub conversation. And so you and I need to talk about that later. But no, thank you, John. Thank you for everyone who has continued to listen through this. This has been episode 31 of Manufacturing Hub with me, Dave, and this guy down here over here, Vlad. John Pillar, thank you very much. Thank you to Copia for sponsoring the theme. If you guys have somehow managed to make it this far, please leave us a like, subscribe. We're supposed to ask for 5 stars on iTunes because we're semi-professional podcasters, kind of, sort of, not really at this point. And until then, we will see everyone next week. Thank you all.
Thank you, everyone.
Yep.